So now when flag is appeared as part of the data, in order to avoid it is not end of the frame, it is appeared as part of the data, then sender should send the data in such a way that an additional byte is added before flag in the data, So if you observe this one, this example, we have this data flag and escape. So now whenever there is a flag in the data, that is preceded by escape. Now one more problem to be addressed is, if escape itself part of the data, then how do we avoid it? So whenever escape is present as part of the data, that also preceded by one more escape, So if you see this one, this is original data and this is byte stuffed data. Whenever there is a flag which is preceded by escape, and whenever there is escape as part of the data, again that is preceded by escape. Now what happens at receiver side, means the methodology is very simple. Receiver will keep on reading the data. Whenever it come across flag, okay, it will understand it is beginning of the frame, and it keep on reading the data. Whenever it come across escape, immediately it will skip this flag. So meaning of that one is, it is never considered as end of the frame. So whenever receiver come across escape, it will skip the next byte, So now what happens in this case is, it will remove this flag, and next it will remove this escape, and next flag is ignored. So as it is, flag is there in the data. Now whenever it moves in the forward direction, whenever it come across escape, immediately that escape is removed, because we have a rule that when escape is present as part of the data, it is preceded by one more escape. So definitely a pair of escapes are existed in this entire data. A pair of escapes are existed. So why pair of escapes are there means, pair of escapes are there because one escape is added before original escape in the data. So see this. So before this escape, this is added one, stuffed one. So that stuffed one is removed, and next escape is as it is there in the data. So escape is there, and it continuously reading. Whenever it come across flag, so it will identify it is end of the frame. So this way byte stuffing and unstuffing is taken place. Byte stuffing means inserting additional byte into the data whenever there is a flag occurrence or escape occurrence. Whenever flag or escape is part of the data, that should be preceded by one escape. And the process of removing this stuffed content at the receiver is called as unstuffing. Whenever it reading the data, when escape comes, it is going to ignore the next byte by removing that escape. When escape comes, it will keep this as it is by removing this one. See this, in the result there is no this escape. And similarly here, when escape comes, the second one is ignored, means it is continuously pushed into the result, but this escape has to be removed. So this way, whenever it come across flag, then it is end of the frame. And in this way, byte stuffing and destuffing is taken place in order to implement framing concept. The framing is a process of identifying where that frame will begin, where the frame will end. And this character oriented methodology comes under variable size framing. Okay. And in next slide, we will talk about next protocol, bit oriented protocol. So the problem with this previous method is, let us see one more time. So the problem with this previous method, when flag is part of the data, additional byte is included. In the same way, when escape comes in the data, one more additional byte is added. So now, if flag escape comes more than one time or 100 times, let us say, in this data, flag and escape comes 100 times. When 100 times this flag and escape occurred in the data, 100 additional bytes are added like escape sequences. 100 additional bytes are added. So definitely it is going to have more size with this stuffed data. So by stuffing such kind of escape sequence, the size of the frame becoming more and more, when data consisting of frame and escape repeatedly. So if frame is more, if frame size is more, data transfer will take a lot of time, more bandwidth is required, all these things comes into picture. In order to avoid this one, in order to avoid insertion of lengthy content into the data, lengthy content in the sense bytes we are adding. Instead of adding bytes, why can't we do with one bit? Why can't we do with the one bit? That's the reason next category of protocol is considered as bit oriented protocol. Stuffing is done by inserting one bit in information, not one byte information. So how it will work means, now if you see this one, a special pattern is considered as a flag here. Special pattern, see previously it is character. Any special character is considered as a flag. But in this case, a special sequence, zeros, 0 followed by 6 ones followed by 0 is a special sequence. And that is considered as flag. That is considered as flag. So now flag is here. So it will indicate start of the frame, and later on you have your data, frame data, header, all these things are comes under frame data. And then at the end again, if you have 0 followed by 6 ones followed by 0, it is a byte actually, it is a byte. Flag is represented with byte with 8 bits which are 0 followed by 6 ones followed by 0. This special sequence of bits are used to represent start of the frame and end of the frame. Now again we pose the same question, that is, if this special pattern appears as part of the data, how we will avoid it? How we will avoid misinterpretation of this starting and ending? So if this special pattern appears as part of the data, how it is identified and what is the solution we will do? So in order to avoid this problem, we make use of a methodology called bit stuffing. Bit stuffing. Bit stuffing means adding one bit into the data to avoid when data consisting of this special pattern is part of the data, not end of the frame. That we need to indicate. That is indicated by doing a procedure called bit stuffing. Bit stuffing. So let me explain that one in next slide with diagram. So now if you see this one here, this is the data coming from the above layer. This is the data which is coming from the above layer. And then I said already, data link layer functionalities, it is going to take the packets from the above layer. Header and trailer is added. Frame is prepared. And when frame is prepared, we need to identify which is starting and which is ending. So before this frame, a special pattern is added, that we call it as a flag. The sequence for flag in bit oriented protocol is 0 followed by 6 ones followed by 0. That is a special pattern, and that is added at beginning and ending. Now if it is occurred as part of the data, how it is avoided means, whenever you come across continuously 5 ones in the data, then it is preceded with it is added with one more 0. In order to avoid this pattern of flag will contain what? 6 consecutive ones. 6 consecutive ones. Now if 6 consecutive ones there in the data, that can be considered as end of the frame, but we should not do like that. So if 6 consecutive ones are there in that data, then we can represent that data by adding 1 0 after 5 ones. Every consecutive 5 ones, 1 0 is inserted. That is, we call it as stuffed. 1 0 is stuffed. If it is so, then you never get a pattern like a continuous 6 ones in the data. I repeat, if you observe in this diagram, see this. Here we got 1. How many ones? We have more than 6 ones. So then what they are trying to do is, whenever we come across 5 ones, 1 0 is inserted. Stuffed. 1 bit is stuffed. So that if you take this one, here we got 6 ones which is preceded by 0 and 0. Originally speaking, the same pattern is used for the flag. The same pattern is used for the flag. So whenever you start reading like this without stuffing, then what happens means, here itself flag is encountered. The system receiver will understand this is the end of the frame, but it is not end of the frame. Still more data to go. To avoid such misinterpretation, what happens means, whenever we come across 5 ones in the data, that is inserted with one more 0, so that you never face flag as part of the data. You never face flag as part of the data. So now see this, 6 ones are appeared twice. 6 ones are appear here, 6 ones are there, and if you observe here, 5 ones are there. Okay, 5 ones. Whenever 5 ones are there, one more 0 is inserted. Whenever 5 ones are there, one more 0 is inserted. Okay, so likewise the content is inserted with bits. Now, how this added content is removed to get back your original data means, at receiver side, when a frame is received, okay, we got flag, it is beginning of the frame, header, all in header information, we start reading the data. When we start reading the data, whenever it come across 5 ones, it will remove next bit. Whenever it come across 5 ones, definitely after 5 ones, 0 is there, but that 0 is not part of the data, that is stuffed by the sender, because in order to avoid the flag in the data, after 5 consecutive ones, 1 0 is added by the sender. That 0 has to be removed by the receiver now. So that is the same procedure. So whenever it reaches, come across 5 ones, it removes that 0. It removes that 0. And similarly, keep on reading. Whenever we come across 5 ones, the next inserted 0 is removed. Likewise, we are going to get our original data back by unstuffing the bits which are stuffed at the sender side, So this way, we are able to recognize where the frame is beginning, where the frame is ending, with the help of special pattern. If special pattern is appeared as part of the data, then we make use of bit stuffing or byte stuffing to avoid this problem. Okay, so this way these two will work. Okay, and in next slide we will talk about one more way of implementing this framing concept, that is physical layer coding violations. In physical layer coding violation, the scenario is very simple. Now data link layer is not having additional bits like this, so physical layer is going to send the data in the form of zeros and ones always. A signal is represented with 0 and 1, high and low. Data, whatever it may be, data is represented with high and low or low and high. Now, what it is going to do is, at physical layer itself, if there is a pattern of high and low is considered as starting and ending. So this logic is not played by the data link layer. This is played at a physical layer. Physical layer will send the data always in the form of high and low or low and high pattern. There are some physical mediums where the data is transferred like high and low. One bit is represented with high and low, and next bit is other bit is represented with low and high. So like high and low combinations, low and high combinations will represent the data. But in order to represent where original signal is started and where it is ended, they can make use of a combination like a high and high combination and low combination, which are generally not used for the data. Those are used for representing starting and end of the frame. This way, physical layer coding techniques also used to identify where frame is beginning and where frame is ending. Now we are not adding anything in this method, we are just changing the pattern of the signal. At a physical medium side, the signal pattern is changed. Instead of using data represented format like high and low and high, they will make use of high and low to represent start of the frame and end of the frame. This way, framing concept can be implemented in 4 methods. I repeat, it can be implemented with character count, which comes under a method called fixed size framing. It can be implemented with the character oriented protocol or character oriented approach, or bit oriented approach, or physical layer coding violation. These all, the last 3 comes under variable size framing. The first one comes under fixed size framing. Okay, so that is the first responsibility and first design issues of the data link layer. Now if you see next responsibility, that is flow and error control. Okay, in this case, flow means when 2 systems are connected to each other, when sender is sending the data, receiver will receive the data. If receiver is not capable of receiving the data, that receiver will send an information to sender saying that my buffer is almost full, or I am already busy with some other work, so can you send me little bit slower, or can you suspend the sending process for a while. Like this, some information has to be pushed back from the receiver to sender, so that sender can change its transmission speed, all these things. Then sender can react according to the request of the receiver. If it is not there, if this methodology is not there, what happens means we are not aware of what is happening at the receiver. We keep on sending the data just like that. We keep on sending the data irrespective of what is the status of the receiver. Then what happens finally means, if receiver is not capable of taking this data, the data is entirely lost in the middle, so that it is loss of data. You send the data as a sender, but it is not received at the receiver side. It is just like that, it is keep on pushing. So such things must be avoided by using a methodology called flow control methodology. And there is one more responsibility or design issue of this layer called as error control. Error control means if data is moving from one system to another system, in the middle, if something goes wrong, like data is lost, we send the data, but the data is lost, not received received at the receiver side. Then how we will come across that error? How to rectify that error? We have sent but not received. And if you have sent, but in the middle there are intruders or hackers changed the content and sent to the receiver. Anyway, you have sent and that is received by the receiver, but not original one, corrupted one. Corrupted one is received at the receiver side. How do we identify there is a corruption? And if you identify, how do we recover from that corruption? Such kind of things comes under error control methodology. Error control and flow control are one of the major design issues of the responsibilities of the data link layer. So now we will see one by one. The first one is flow control. There are many protocols existed to implement this error control and flow control. Okay, protocols are divided into two types called noisy protocols and noiseless protocols. Protocols developed for noisy environment, protocols developed for noiseless environment. Generally, noiseless environment, we never come across noiseless environment. Always we are in noisy environment only. Definitely there is a chance of getting noise in the middle. So if it is the case, then what are the precautions we need to take? Those things must be addressed with the help of noisy protocols. For the sake of theoretical issues, like if there is no noise, how data will go? It is only for the purpose of research and reference model, we make use of noiseless channels also. We consider that it is very good. If it is very good, how data transmission is taken place and what are the rules to be included in the protocol. So based on this concept, these two are divided into two types called as noisy and noiseless protocols. Okay, I'll show you the taxonomy. See this one. The protocols in data link layer to handle flow control and error control. Flow control only as of now. Error control again we'll talk about those protocols later. Flow control protocols are in data link layer are categorized into two types called as noiseless channels and noisy channels. Under noiseless channels, whatever the methods we discuss are reference models only, not existed in real life. Because in real life, we are in noisy environment. So external influences are there on our data. If external influences are there, what are the rules to be followed to make our data transfer successful? That is most important one. This is only reference model. Like if it is so, like if there is no noise in the middle, then how our data transfer will take in place is implemented, is dictated with the help of these two methods called as simplest method and stop and wait protocol. So at this side, noisy channel, if noise is existed in the middle, definitely there is a loss of packet, corruption of the packet. Packets may be resent because of many reasons, like duplicate packets are, likewise there exists many issues to be addressed in noisy channels. All these issues are addressed with the help of these protocols called stop and wait protocol, go back and protocol, and selective repeat ARQ. ARQ stands for automatic repeat request. In this data link layer protocol, if data is missing in the middle, if data is not properly sent to the receiver, the first and foremost solution is retransmission automatically. After certain moment of time, timeout period is there. We have sent a packet after some certain timeout that is not acknowledged. In that case, automatically that packet is again retransmitted. That automatic retransmission is called as ARQ, automatic repeat request. Automatic repeat request. So this noisy channel method, data link layer make use of a protocol called ARQ with different rules. One is stop and wait, one is go back, and one is selective repeat. We will talk about this first, for noiseless channels. For noiseless channels, the first one is simplest. As per that methodology, in simplest protocol or method, what happens means the data is transferred from sender to receiver. Data is transferred from sender to receiver, and only one direction of data is existed. Like sender will send the data, and those frames are sent in the through the channel. Only one channel is existed, unidirectional. Sender is going to send the data to the receiver, and where data frames are sent. And what is the job of the receiver means it is going to take the frames one by one, and that is hand over to the above layer called network layer. So the methodology of this simplest, the name itself indicates simplest means it is not going to handle flow control, it is not going to handle error control. Why it is not handling flow control means, see, if you observe here, the sender will keep on sending the data, not waiting for the acknowledgement whether it is received or not. No information is given back from the receiver to sender. As it is not acknowledged, then there is no flow control at all. Like you don't know whether this packet is received at the receiver properly or it is lost in the middle. It is not going to lost because it is noiseless channel. In noiseless channel, no packet is lost. That's the reason no flow control mechanism is required, because see, if you are very good, if you are concentrating here, then whatever I talk, you can reach out. That we call it as noiseless environment. If you are in some disturbance, whatever I am talking, it may be lost in the middle, and there should be a way of giving me a replay from your side, like, sir, I didn't get this point. Then what I do is I retransmit the same topic. Such kind of flow control is existed when you are in a channel called noisy channel. But this methodology is what? A noiseless channel. If it is noiseless channel, the sender will keep on sending the data frames, and those frames are received at the receiver. That's it. Okay. And no error control also. Error control is not at all required, because is it going to have any error means no errors, because you are in noiseless channel. Noiseless channel means no external influences. So definitely your data will go to the receiver, your data is never corrupted. That's the reason the simplest method will not handle that flow control or error control, because that is not required in this medium, noiseless medium. Okay. So that is the job of the simplest protocol under noiseless category. Okay. Now if you see this one, when packets are sent from sender to receiver means when there is a request from the above layer, network layer will give the packet, then we need to send it. So there should be a notification from the above layer to data link layer, right? That we call it as event. Request from the network layer. When network layer prepares the data, push it to the data link layer, then there is a job to the data link layer to push that one onto the channel. So that is one event. So when data frames are sent from sender to receiver means when network layer of the sender will put a packet to the data link layer. When such event is occurred, then data packets are starting its journey. Okay, only one event. So this is this process is repeated forever. When there is a input from the above layer, it is going to send. And what happens at this side means from where data packets are received by the data link layer means it is from the physical layer. So physical layer will give you an information to the data link layer saying that we have received a data frame. When data frame is received, then there is a job for the data link layer to extract it and send it back to the network layer. So here also data link layer is waiting for one event. That event we call it as notification from the physical layer. When notification occurs, this data link layer is activated and it is going to do its job. So this process is repeated. It is waiting for an event. That event is occurred from which layer? Physical layer. And here also, this data link layer is waiting for an event called as notification from the network layer. When data is there at network layer, it will notify, then it will start its work, send it. When physical layer will give the data to data link layer, then it is notified by the physical layer, then data link layer is activated and send the data to the above layer. This we call it as simplest protocol in noiseless environment. So this is a total data flow. So if you see the algorithms, see this, the algorithm at receiver side. At receiver side, what it is going to do is, I think actually this one is at sender side. You just try to understand, this is at sender side. Okay, and sender side, the text is written like that. At sender side, waiting for an event. Which kind of event? Packet coming from the above layer, that is network layer. When that event occurs, get the data, make a frame, send the frame. This is a work done by the sender. This is a work done by the sender in simplest protocol. Okay, don't confuse, here we have written like a receiver, but it is not. It is sender side algorithm where it is waiting for an event. That event we call it as packet coming from the above layer, that is network layer. And now if you see a receiver side process, at receiver side algorithm for simplest protocol is, what receiver side data link layer is doing means, it is waiting for an event. Which kind of event? Notification from the physical layer. Notification from the physical layer. Physical layer will give you information saying that one data frame is arrived. When frame is arrived, what it is going to do is receive the frame, extract the data, the frame consisting of data, right? The data is extracted and that extracted data is delivered to the above layer, that is network layer. So this process is repeated for receiver at simplest protocol. So these two algorithms are continuously running at both sides, sender and receiver. This is the simplest method. The data flow is very simple. It is moving from only one direction. Flow control in simplest protocol is like this. When there is a request from the above layer, data link layer will send the frame. One more request, one more frame. One more request, one more frame. But if you observe, there is no backward data transfer. But there is no backward data transfer. So this way, simplest method will work. Right. So there is one more protocol called stop and wait protocol. Stop and wait protocol under the same category, that is noiseless channels. In case of stop and wait, it is going to address the problem of this acknowledgement problem. Okay, acknowledgement problem. Acknowledgement in the sense, data is moving in both directions in this protocol. Data flow is there in both directions, but one channel is used for sending the data frame and the other channel is used to get the acknowledgements. Acknowledgements means, okay, the data is received by the receiver and receiver will send a information to the sender saying that I have received it properly. When you get an acknowledgement properly, then automatically one more frame is sent. Likewise, the design of stop and wait protocol is existed, which is going to implement flow control now. Flow control in the sense, when you send a data, that should be acknowledged. That should be acknowledged. Once you got acknowledgement, again we send one more data and that is acknowledged likewise. So now if you observe this methodology, this data link layer is having two events now. When data is coming from the network layer, it has to prepare a frame and it send it. When you got an acknowledgement, see this notification from physical layer. Again, when you got an acknowledgement, what it is going to do is, again it is going to prepare a frame. Okay, we need to send second frame. We need to send a second frame. So this way, frames are sent when those are acknowledged by the receiver. And at receiver side, the job of the receiver is, it is going to receive the packets from the physical layer. Okay, when there is an event from the physical layer saying that I received a frame, then it is going to process it and send it to the network layer. And then again, immediately what it is going to do is, it is going to send a reply back to this system, reply back to sender side system. That reply we call it as acknowledgement. So this is a general methodology to implement stop and wait protocol. In stop and wait protocol, flow control is considered and every packet sent is going to be acknowledged, so that based on the acknowledgement, sender data link layer will take next action. If next frame comes, then it is going to send. So this way this method will work. So this diagram will show you flow control, how the data is flowing from one to another. Sender will send a request. We got a request from the network layer, so we will prepare a frame and send it. Whenever it is received by the receiver, what it has to do is it has to acknowledge. Once acknowledgement is received, then if you got one more request, then you are going to prepare a frame, send it to the receiver, and receiver will send an acknowledgement. Acknowledgement is arrived, then if there is one more request, and that is processed. The flow is moving like this. So this way, this channel, that noiseless channel is implement. These protocols are comes under noiseless channel. One is simplest protocol and another is stop and wait protocol. These two protocols are comes under noiseless channel. We have not come across any error. If error happens, if frame lost in the middle, what action is taken? If acknowledgement is lost in the middle, what action is taken? These are not considered under this environment because it is a noiseless environment. These all issues are addressed at the other wing, that we call it as noisy wing, noisy channel protocols. Those protocols we will see in further classes. Okay, let us stop.